Welcome back. Let's review the equations that we've learned so far that help us explain position time graphs. So real quick, here's a position time graph. The position is on the y-axis, time is on the x-axis. So this point B, that's at 5, 2, that means at 5 seconds, the object was at 2 meters. There's several important things that we want to be able to find from this graph. How fast and which way was the object going in any one of these line segments? And how far did it travel between any two points? The how fast and which way part is the velocity. The how far and which way is the displacement. We're also going to find speed and distance from those. Make your paper like my board. Question 1 asks, calculate and state the velocity of the object during interval fg. Velocity takes 2 points to calculate. The 2 points are defined by the interval it's talking about. Since it's talking about interval fg, I'm going to use point F and point G. I'm going to look at my graph. I see that point F is at 25 seconds and 8 meters. And point G is at 30 seconds and 0 meters. I'm going to write those in. 25S, 8M, 30 seconds, 0 meters. Great. This is what I mean by listing givens with units for a velocity problem. Next, we have to write the equation. The equation for velocity is x2 minus x1 over t2 minus t1. Put another way, it's position 2 minus position 1 over time 2 and time 1. Which of these is which? Well, here's the first point I listed. Here's its time. So this is time 1. First point, position 1. Same for the bottom, except it's the second point, so I have time 2, position 2. Great, we're ready. We've written our equation, let's put a check. Now we're going to substitute the values into the equation. I see that x2 is 0. I see that x1 is 8. t2 is 30. t1 is 25. I've substituted. Now I'm going to simplify this so I can get my answer with units. Moving back up, I have 0 minus 8, that's negative 8. 30 minus 25 is 5. Putting that into my calculator, negative 8 divided by 5, I get negative 1.6. Negative 1.6, and I know that velocity has units of meters per second, so my answer, meters per second. We're not done. Since velocity is a vector, it has to include a direction, so I'm going to write it out. The velocity is 1.6 meters per second in the negative direction. Cool. Let's skip ahead to this is what I mean by velocity statement. Let's skip ahead to number 3. Number 3 is not asking for velocity, it's asking for you to calculate and state the displacement of the object between points B and F. I'm going to start by listing my givens. Delta x b f means the displacement between B and F, and you need to know the position at B and the position at F. I can read those off the graph. Here's B. It's at a position of 2 meters. I'm going to write x equals 2 meters. And here's F. We already know its position. It's 8 meters. B is 2 meters. F is at 8 meters. I'm going to write that in. B was at 2 meters and F was at 8 meters. Bam! I've listed my givens with units. Next I write the displacement equation. The displacement between 2 points, 1 and 2, is the position of the second point minus the position of the first point. Substituting in, my second point was 8 meters position. First one was 2 meters. That gives us positive 6 meters. So I wrote my equation. I wrote my substitution, 8 minus 2, and I have my answer with units. I'm not done. Just like velocity, displacement is a vector, which means it includes a direction. So I'm going to write it out. Displacement is 6 meters in positive direction. That's my displacement statement. Great. Now let's look back at number 2. Number 2 asks us to calculate the speed of the player during interval fg. Look real quick back at our answer for velocity. Our velocity is 1.6 meters per second in the negative direction. This part of the velocity, the 1.6 meters per second, is the speed. Let me show you how to get that algebraically. So for finding speed, when you know the velocity, you would say, I want to know the speed. And the velocity is 1.6 meters per second, negative direction. That's how you list givens with units. Moving on, I have to write my equation. So I told you that the speed was this part. How you show that algebraically is that you would say that the speed is the magnitude of the velocity, meaning just this part of the velocity. That's what the double bars mean. I wrote my equation. I substitute. My velocity was 1.6 meters per second, negative direction. I do the double bars operation, which means keep just this part, and I have 1.6 meters per second. Done. Let's look at number 4. Just like speed and velocity have that relationship, distance and displacement have that relationship as well. Remember, we found the displacement was 6 meters in the positive direction. This 6 meters part, just this part, is the distance. So for number 4, when I'm listing my givens, I would say that the distance is what I want to know, and I have the displacement. It's 6 meters in the positive direction. That's listing my givens. The equation is distance is the magnitude of displacement. Distance is the magnitude of, I wrote my equation. I'm going to substitute. Distance is the magnitude of 6 meters positive direction. I perform the magnitude operation, which means keep just this part. My answer is 6 meters. Cool. Using your notes in this video, complete at least 2 of the problem sets from pages 6 through 8. So you should complete at least page 6 and 7. If you get stuck, watch this video again to see how I got through the solutions, and then raise your hand for help. You got this.